Good morning, students. So today I am going to explain the analog and digital communication lab. In that, the third experiment is double sideband suppressed carrier. So this is the double sideband suppressed carrier trainer kits. Here we are having separately transmitter and receiver kit. So to observe the waveforms, I am using the digital CRO. So in the DSB-SC, we are having simple block diagram which is called as balanced modulator, which will take audio oscillator signal as message and carrier signal from the carrier generator too. So this is the transmitter kit. The output of the balanced modulator will give double sideband suppressed carrier signal, and this is the receiver kit. So from the product detector, simply here also we are using balanced modulator, but in the receiver we are calling that as a product detector. So that product detector will give the output as recovered message signal in the double sideband suppressed carrier receiver, that is called DSB-SC receiver. So I am observing the message signal from the audio oscillator, which consists fixed amplitude and fixed frequencies. So the frequency range given in the audio oscillator is 300 Hz to 3.4 kHz, and the amplitude is 0 to 2 volt peak to peak. So now I am observing the message signal from the audio oscillator in the CROs. So connecting the positive knob of this CRO to the audio oscillator as a message signal output. So this will give the message signal on the screen. So let example 1 kHz frequency and 2 volt peak to peak message signal. So this is the sinusoidal message signal is given to the balanced modulator, and along with the message signal I am using carrier signal also from the carrier generator too. So this carrier generator will give the 400 millivolt peak to peak amplitude with 455 kHz frequency. Now to observe the carrier generator, connect positive knob of this CRO to the third pin across the carrier generator too. So this will give the carrier signal. So to observe properly carrier waveform, adjust the horizontal knob, it will give the carrier signal, and we can reduce the voltage signal also. So this is the carrier signal with the amplitude 400 millivolt peak to peak and 455 kHz. So this carrier signal and audio signal, that is message signal, both are given to the balanced modulator. So message signal is coming to the balanced modulator, and carrier signal is also connected to the balanced modulator. Now observe the output of the balanced modulator, which is called DSB-SC signal. So here I am connecting the positive pin of the CRO to the DSB-SC output. So this will give the DSB-SC signal. So to understand properly, you can adjust the horizontal knob and the voltage knob also to understand properly. So this is the DSB-SC signal we are getting from the balanced modulator. So from this we can calculate the amplitudes of the peak to peak values and the frequency values of the signal output also. So to observe the received signal from the receiver, I am connecting the transmitter to receiver with patch cords. So transmitter output is connected to the receiver input, and the ground is connected with a patch cord. Common ground is connected between transmitter and receiver. So this is the receiver kit. So here we are having the product detector. So this will give the final recovered message signal. So to get the proper amplitude levels of the recovered message signal, this is given to the audio amplifier. So at this point we can get the recovered message signal as a DSB-SC demodulated waveform. To observe the DSB-SC demodulated signal, I am connecting the CRO probe positive pin to the audio amplifier in the receiver section. So from the product modulator to audio amplifier, the connection is done. So with the LED, this will connect it together. So the output of the demodulated DSB-SC signal from the audio amplifier is available on the screen with same frequency as given in the message signal frequency, which is transmitted from the transmitter. So this will give the final circuit of the DSB-SC modulator and demodulator. Thank you.